This roof collapsed while people were still skating underneath it. It had stood for over 30 years without a single warning sign, and when it finally gave way, it killed 15 people. Investigators confirmed the material holding that roof up was wood, the same stuff you picture in tree houses and campfires. Here's the twist. Right now, engineers are using that exact same material to build 18-story skyscrapers, and trusting it more than ever. So which is it? A death trap or the future of construction? To actually answer that, we have to rewind about 120,000 years. Long before concrete, before steel, before anyone had ever used the word engineer, humans were already building with wood, and it worked for one incredibly simple reason. The very first human shelters were just branches and timber leaned together because wood was everywhere, and, unlike stone, you could actually shape it with basic tools. No factories, no supply chains, just a forest and some patience. Then, around 4,500 BC, something changed. Humans stopped wandering and started farming, which meant they finally needed buildings that would outlast a single season. So they built the first real longhouses, permanent load-bearing wooden structures designed to stand for generations, not just survive one winter. Fast forward to ancient China, where builders were doing something that looks almost like cheating, raising wooden pagodas that could survive earthquakes without falling over. One of them in Yingxian has been standing since the year 1056. The trick was flexibility. Thousands of interlocking wooden brackets that let the whole tower sway like a tree in wind, instead of standing rigid and snapping like a dry branch. Over in Japan, there's a temple complex still standing from around the 7th century, making it one of the oldest wooden buildings on Earth. And here's the part that sounds impossible. It was built without a single nail. Every joint is wood carved to interlock with wood like a puzzle piece engineered to survive over 1,000 years. Norway and Russia pushed the idea even further. Their stave churches and log chapels, some dating back to the 1200s, used zero metal fasteners, and a few are still standing 8 centuries later, having outlasted the empires that built them. So how did Northern Europe build so much with wood? Simple. They had forests to spare. By stacking whole logs on top of each other, they made walls where the timber itself carried the load sideways, across the grain, the natural lines running through every plank. The wall wasn't just a wall. It was the entire structural skeleton of the building. Meanwhile, in Switzerland, the Chapel Bridge in Lucerne was built around 1360, making it the oldest wooden bridge in Europe. It survived floods, wars, and over 6 centuries of foot traffic. And then, in 1993, it burned down because of a dropped cigarette. Turns out gravity was never wood's real enemy. Fire is. Central Europe found a smarter way to save timber: half timbering. Instead of stacking solid logs, builders exploited the fact that wood is incredibly strong when you squeeze it along its length. So they built a skeleton of angled beams to carry the weight, and filled the gaps between them with cheaper material. Same strength, way less wood. And houses built this way in the 1500s are still lived in today. Jump to 19th century America, and timber construction gets a serious upgrade. Balloon framing. Thin, cheap studs run the full height of a building in one continuous piece, with each floor simply hung off the wall like a shelf. It was fast. It was cheap. And it's basically the reason entire frontier towns could go up in a matter of weeks. By the 1960s and 70s, builders went even further, assembling entire wall panels in a factory, framing, insulation, and sheathing already built in, then shipping them to the site to click together almost like oversized Lego bricks. This is the direct ancestor of most suburban houses standing today. But here's the real reason wood is making a comeback right now, and it has nothing to do with nostalgia. As a tree grows, it literally pulls carbon dioxide out of the air and locks it inside its own wood. Roughly half of dry wood, by weight, is pure stored carbon. Producing the same volume of concrete or steel, on the other hand, pumps enormous amounts of CO2 into the atmosphere. Build with wood, and your building becomes a carbon vault instead of a carbon source. So engineers got creative. They started gluing thin boards together into single beams stronger than the sum of their parts. a technique called glue-laminated timber. Then they went further, layering wood at right angles like giant plywood to create cross-laminated timber panels that behave almost like concrete slabs. The result? Buildings like Vancouver's Brock Commons, 18 stories, mostly engineered wood, built in a fraction of the usual time. Which brings us back to that collapsed roof. It was also built from glue-laminated timber beams. The exact same engineered wood technology we just called the future. So what actually went wrong? Investigators found the snow that day wasn't the real killer. It was moisture quietly seeping into the beams for over 30 years, rotting the wood from the inside out, completely invisible from below. The wood itself wasn't weak. It was decay nobody could see, hidden inside a beam that looked perfectly fine on the outside, right up until the moment it wasn't strong enough to hold the roof anymore. It's a brutal reminder that with wood, what you can't see can absolutely kill you. So, is wood a death trap or the future of construction? Honestly, it's both, and neither. It's a material humans have trusted for over 100,000 years, one that's now holding up skyscrapers, and one that will keep delivering both miracles and disasters for as long as we underestimate what it actually is. Which raises the real question: what actually makes wood so strong in the first place? And so easy to get catastrophically wrong? That's exactly what we're breaking down next. If that made you look at something ordinary a little differently, that's the whole point of this channel. Hit like and subscribe if you want more of this, the hidden engineering behind the stuff you walk past every day. And tell me in the comments, what's something you use constantly but have no idea how it actually works? That might be the next video.